play a couple of these little games for fetch points to get like gift cards and stuff because I'm anyway. And I got it was so solitaire. I was matching the number, and I got six. And you can go forwards or backwards. So it was 6, 7, 6, 7, and it went back and forth like 3 times. So I was like, oh, if Henry was here, he would have a fit. All right, number 9. Henry, you really don't look like you feel well.
Miss McGee.
Yeah.
Miss McGee.
What?
Do you have an extra one of those?
Oh, she's throwing you under the bus.
I left yours on your desk. Well, I had yours and you had mine. I bought yours.
All right, number 9. So remember, this is where we're factoring given a factor, okay? So I've got, and all of these are going to be set up to do synthetic division. Plus 12x plus 48, and I am dividing by x plus 4. So what goes outside the synthetic division sign? -4. I want to change that sign. Do I need placeholders? Nope. -1, -4, 12 and 48. -1, 4, 0, 0, 12, -48, 0. Everybody good? Write it as a factoring problem. Or write it as a multiplied problem. So I got x plus 4 times what? Can I factor anything any further? No. So I'm going to go ahead and set each piece to 0. You could factor out a -1 here. I'm inclined to factor out negatives if my leading coefficient is negative. You don't have to, though. So if I do x plus 4 equals 0 and -x squared plus 12 equals 0, I get -4 being 1. And then -x12 equals, or -x squared equals -12. What is wrong with my pen today? So I got plus or minus square root of 12. And then what? Four and 3. So 2 root. Y'all haven't even asked me about your quizzes. I kind of forgot about them, honestly, because I had to meet with Miss Montgomery during my planning. It was supposed to be 15 minutes, and it was the entire block, and so I sat them there and forgot. All right, there's my other 2. So I haven't graded for you more. Apologies. So 1, 2, 3, what did I start with? Indeed, it was a cubic. Anything else from your homework? Number 10, how do you factor out? Let's see. Oh, that's a cube. Did you do your placeholder? Let's see. 1, -3, 0, 27, -81. So drop it, multiply, add, multiply, add, multiply, add, multiply. Oh. X cubed plus 27. What do you notice? They're both perfect cubes. This is a sum of cubes. This is a little parenthesis, big parenthesis. I know, I'm sorry. So I got x minus 3. I got little parenthesis, big parenthesis. Tell me the signs. Same, change, plus. X and 3. And then use that to set up your second parenthesis. X squared. 3x. No. Even if you got this far, you might have still gotten stopped because these are easy, yes. Oh, Miss Edwards is just a teacher. What do I do with this, though? I have to do quadratic. That will always be a quadratic formula, every single time. So, nothing to it but to do it. Opposite B plus or minus square root. Keep going, Katie. Why? You are doing good. B squared minus what? 4AC. What? Over 2A. Because you're not shy and you started singing it and then you act like you're shy. Your hair looks good today. Did you get it cut? It looks different today. Did you do something different to it? No, it looks good. So it looks longer, maybe. I just know that. Alright, so 3 plus or minus the square root of 9 minus 36 over 2. What's 9 minus 36? Are y'all asleep? Wake up. Negative 27. Not 67, Henry. 27. I can split it up with what and what? 9 and 3. So I get 3 plus or minus 3I root. Are y'all okay? Do I need to come like dance up here for you or something? No, thank you. It's a joke. A snow dance? It feels like it could snow. One of my friends sent me a picture last night and she had a fire in her fireplace. I told her it's a little early for that. We hadn't even flipped.
We had our fire done.
No, y'all did not. We have not even flipped our heat on yet. I refuse. No, we don't. We're not turning the heat on this early.
Even when it gets like
This all came from the sum of cubes. All right, y'all ready to keep it moving? Huh? Yeah, you'll turn in the whole packet.
Is it like x minus 3x plus 10?
Well, it's what multiplies to 2 but adds the negative 3. So negative 2 and negative 1. So the x minus 2.
So it's like that.
Yeah. All right, let's do the last part. This takes us through, so we did factor given a factor. Now we're going to do find the zeros given a 0. And then we'll have the all-encompassing PRZs, which bring us to the end of the unit. So we should be able to finish the unit today. All right, find all zeros. You're going to see that this you've really already done. I won't camp out here a long time because if you can do the factor given a factor, you can do the find the zeros given a 0. Okay. Number 12. There's a little blurb right before it, but it's just like a recap. Remember when you plug in a 0, you should get what? Okay, so if I were to go back to one of these, 0, if you plug in an x-intercept, you should get 0 because x-intercepts happen when y equals 0, right? Say right, right. Okay. What do you mean? It still stays the same. The only thing that changes is when you divide, you change that sign outside. Do you know what I'm talking about? Like this said the factor was x minus 3, so we put a positive 3 outside. So while we're here, as we get ready to jump into this next part, what what is the relationship between the factor and the zero? The zero is the solved, but notice too. Okay, so here's my zero. This is my zero, right? Which is the same as here. They're opposite signs of the factor. Yes? And we already know that from solving quadratics, right? With me, Katie? What are you smiling about? Okay, so what happens if I have, this is like number 12, or this is number 12. I have this polynomial, and I need to find all the zeros, but I cannot factor it. I don't know how to factor that, right? But they give me a zero. They say that one of the zeros is 4. What can I do to find all the other zeros? That's exactly what you do, Henry. I turn this into a problem like I've already done, and I say, so let me put your note. Make a factor from the zero. So if 4 is the zero, then what's the factor? X minus 4. Yes? Does that make sense? Everybody okay? Do you know how to factor given a factor? Say yes, because that's what we did last week. Yes. Okay, so let's pick up with what we did last week then, and it's the same exact problem now. You just have to keep straight of really the signs is what you're keeping straight here whenever I divide. So whenever I do my division, what goes outside the division sign? Positive 4. So the zeros are the same signs. The factors are the opposite sign. If you remember that, you'll be A-okay. Opposite of the factor, yes. But it's the same. So whatever the zero is, you put that exactly like that outside here. But when you write the factor, you change the sign. All right, so let's divide it and see what happens. 1, -8, 4, 48. Drop it. Multiply it, add it. Multiply it, add it. Ooh, 8. No, it's 12. Am I going too fast? Running through this sentence. I'm sorry. I'll slow down. Katie, you don't have your flip-flops on today. Did you give Grandma her shoes back? Oh, now she's probably walking around town with no shoes. All right, factor completely. What do I look like now? Factor. Exactly right. I've still got this X minus 4 out front. Can you factor that now? Yes. How does it factor? Perfect. So what are the zeros of this polynomial? 4, 6, -2. Is anybody confused? It's exactly what we were doing. The only difference is we're forming the factors so that we can finish. That's the rest of what I wanted to get through Friday when the bell rang, because I generally do those two together since it's really the same thing that we're working through. All right, let's PRZ it. PRZs encompass everything. Are y'all ready? No. This is the last thing. Probably. We'll see how we get before we get here. So the problem occurs when we have this polynomial. We're asked to find the zeros. We can't factor it. We're not given a factor, and we're not given a zero. And we go, oh no, what am I going to do? Right? Do y'all do that? Yeah. Just kidding. Okay. So here's what we're going to do. We're first going to start with a list. Now, these are just possibilities. That's why they're called possible rational zeros. They might be a zero. They might not be. We're going to check them and see. But they're possibilities. We kind of need a springboard. Before we just jump in testing every single random number we can think of, we want a list of numbers that to kind of narrow it down, okay? And that's what PRCs do for us. So how do we find them? I'm glad you asked. PRCs are every single possible combination of factors of the constant in the equation divided by all the possible factors of the leading coefficient. What do I mean by that? I'm glad you asked that also. Yeah, Katie, I heard you ask. You said, Miss McGee, how are we going to find the possible rational zeros? And I said, well, Katie, I'm so glad you asked. All right. First of all, if I'm asked to find the zeros of this, I'm in a little bit of a predicament, right? Why am I in a predicament, Katie? What do you think?
You keep touching me.
Okay, back up. How do you find zeros? Anybody. What do I do? How do factor? I set it equal to 0 and factor it, but the problem here is what? There's nothing to factor by. I can't factor that, right? I can't slash it. It's 4 terms. That'd be really my only way to go here, and I don't have a springboard to go on. I wasn't given a factor or given a 0. So I'm just in a bit of a predicament. Okay, so what I'm going to do is I'm going to list out possibilities. I need factors of the constant. What's the constant? Okay, here's my constant. Everybody agree? Tell me all the, bless you. Tell me all the factors. Start with the smallest and work your way up, and it'll be easier. 1. And I'm actually going to say positive or negative 1, because if I multiply by a positive or negative, they're always plus or minus. Give me another. 2. Keep going. 4. 8. Is that all the factors? Yes. What is the leading coefficient? What are all the factors of 1? Plus or minus 1. Are we all okay? I'm going to take every one of these numbers and divide it by every one of these numbers and do every possibility. In this case, it's easy because there's only 2 numbers for the leading coefficient. So my PRCs here would be plus or minus. I'm going to take all of them and first divide them by 1, which just gives me itself. If there were another number here, like let's imagine there was a 3, I would take all of these numbers and then also divide them by 3. So 1/3, 2/3, 4/3, 8/3. Okay. So depending on how many factors you are, that's how many your possibilities begin to increase exponentially. Okay. Right now, I just want you to focus on when you write these. You'll have a question on your test that just says list them, not find the actual zeros, but list the possible zeros. So look at the second one there. 2x cubed plus x squared minus 4x plus 1. What's the constant? 1. What are the factors of 1? Leading coefficient. Factors of 2. So the PRZs. Remember, it's this divided by this. So plus or minus 1. Plus or minus, everybody's saying 2. 1/2. Because it's the last one divided by the first one. So you take all of these and divide them by the first number here. And then you take all of these. Let me show you another one. Let me show you one that's not got ones in it like this. This one's not on your paper. I'm just going to make some. Let's say 6x to the 5th plus 7x squared minus 10x plus 15. List the PRZs. So let's do the constant first. What are the factors of 15? 1, 3, 5, 15. What are the factors of the leading coefficient? 1, 2, 3, 6. Now let's put our PRZs together. This is a little bit harder because look at all these numbers I got. All right. Start with these. Okay. I'm going to take all of these and I'm going to divide them by 1 first. So that's just itself, right? Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Now what am I going to divide them by? 2. So I take that same list of numbers and I divide each one of them by 2. Plus or minus 1/2. Plus or minus 3/2. Plus or minus 5/2. Plus or minus 15/2. Now I'm going to divide them by 3. You see how you really don't want one like this? 1/3. 3/3 is 1. There's no sense in repeating 1, so I don't have to do that. 5/3. 15/3 is 5, so I don't have to repeat that one either. Now I divide them all by 6. So I've got plus or minus 1/6. 3/6 is 1/2. That's already on there. 5/6, we're still going. 15/6. What's that reduced to? 5/3. 5/2. That's already on there. So I stop. So there's all my PRZs. That's a lot. But you see how it's harder whenever you have the bigger the numbers get on the front and the back. All right, questions about listing the PRZs. Katie is about to die to know why we do this. She is itching to know. So for Katie's sake, I'm going to show y'all. Y'all can thank Katie. Thank you, Katie.
Thanks a lot, Katie.
Cricket, yeah, where's your cricket button? Oh, I think we'll jump down to 17. All right, some people can, I can't. I just read a book. Well, never mind. Getting off topic. Okay. That is good at getting me off track today.
Come up here and track.
Okay, that would be funny.
I'll ride a track car.
Dozier tried to get them last year to do. This is the last thing I'll say, and then I'll. He wanted to go get. Why do we not call this? All right, Katie's about to die to know why we do PRZs, and I don't want to keep her. She's just on edge right now, so. I need to make sure. What? I told you, I got a speed reader award on Goodreads the other day.
So what does that mean?
I met my goal and I kept going, and I'm still, like, I must have read it quicker than most people, I don't know. Like, you read it fast. Huh? No, Goodreads just tracks everything you've read. And I rate it so I can remember, so whenever, like, people,
You read like the actual book you get online.
I read on my Kindle. I don't know. Did I? All right, Katie, give me my PRCs.
Okay, so one,
One,
two,
two,
four,
six. That's all. That's all. That's it. Okay. So the directions for this problem, these would not be here. It would just say find all zeros. And you're just left floundering to find all zeros, looking at something like that, which is a cortex. So how many zeros should I get?
4.
4, and I don't even know where to start, right? Because I can't factor, there's no way to factor something with 5 terms that I know of. So, I'm going to start testing. Now, I want you to think. If these are real zeros, if any of them is an actual zero, what will happen? It will be a factor. And what happens if it's a factor? No remainder. I can divide it with no remainder. Do you agree? So let's start testing. Y'all don't realize what we have to do yet, or you will be complaining already. Now, at the moment that you find the one that works, you can stop. So we pray we find the one that works first.
Is there ever like multiple that work?
Yes.
Like, is this the one?
I think quadratics is the hardest one. That's the first one.
Wait, Miss, so I guess there's multiple that work.
You stop one. I'll show you. All right. So let's start with 1. Shall we start? And understand that's not just 1. That's 1 and -1. That's 2. And so there's actually 6 possible zeros here. Okay. All right. So we're going to start with 1. This is why exactly. I told you we'd get to the point where you would be glad you knew the shortcut, because what happens if I have to test 10 different ones? I would not want to do that with long division. Okay. 1, 2, -3, -4, and 4. Watch out for placeholders. Y'all okay? Delanus, you good? Okay. Drop it, because it's hot. No, it's not, but just kidding. Okay, 3, multiply nobody. 1 times 3, 3, 0, 0, -4. Holy cow! We found it on the first try. Huh? No. But I will tell you, I always start with 1 and -1. Those are always factors. Those are always a springboard for me. I always start with those 2. If it's not one of those 2, if there's ever like a half or a -half, I always try that. And then I move on from there. But those are kind of my go-tos that I try first. What? Why are you looking like that?
I don't know.
This one goes with this one, and then whenever I multiply it around, I got positive 3. Is that what you're asking?
How did you know we found it?
Oh, because the remainder. Because this is 0.
Everybody said we found it.
Oh, how we're looking for one that gives us no remainder, because no remainder means it's a factor.
What did it remember?
Okay, so because that's no remainder, write it as a multiplication problem. Okay, so now we're kind of back to where we're springboarding with, I know one of the zeros is 1. Can I factor it given that? Because this means that x minus 1 times x cubed plus 3x squared minus 4, is this thing factored a little bit further? Yes? But OMG. How'd you know? God, you're so smart, Quinn. Okay, what am I gonna do? This is what I like to call a double PRZ. Which means, because do we all agree that I have to now factor this? Do you know how to factor that? But it's not a quadratic. Good guess, though. And if that was x squared plus 3x minus 4, yes. But it's a cubic. Blech. I'm going to have to PRZ it again. So, I'm going to have to do this PRZ process all over again. Now, lucky for me, the leading coefficient and the constant are the same. So my PRZ list is the same. My PRZs here are plus or minus 1, plus or minus 2, and plus or minus 4. Now I'm just focusing on this second parenthesis. What shall I try? 1. Okay. Don't forget your placeholder. 1, 3, 0, -4. Drop it, guzzes. What? Okay. Y'all suck. Oh, look! Charlotte, how do I know? It's a 0 on the end. It's a 0 remainder. It worked. Now, is it okay that I got the same 0? Sure. Because whenever you factor, you can have two factors that are exactly the same. We would try the next one. So, like if I tried -1, so I drop it, multiply it, add it, multiply it, add it, multiply it, and I get -2. See how that's not, I know that's not a factor. So then I tried, exactly. And I keep trying until I found one that worked. All right, so now I'm going to rewrite it. Now, this little x minus 1 is still following this guy down. This is split up into x minus 1, x squared, plus 4x plus 4. And I'm always thankful whenever I get down to my highest degree being a quadratic, because I know even if I can't factor it, I can use quadratic formula. Can I factor it? Do I want? You can. You can if you want to. You could write this as x minus 1 squared times x squared plus 4x plus 4. Can you factor that quadratic? Thank the Lord. Okay, because there's one on here that is a double PRZ and quadratic formula, which means you got to PRZ it twice. That's as hard as it'll get for y'all. It's double PRZ and quadratic formula. Yeah, I'm sorry. All right, so how does it factor? This is actually what? Somebody knows it. Which is called a what? Look at y'all go. Perfect square trinomial. It is indeed. It is indeed. If you didn't remember that, this was an easy one to factor x plus 2, which is x plus 2 squared. So, what are my zeros? Because I did all of this. Okay. Okay, so I did all of this just so I could find the zeros. What are the zeros? 1. But this doesn't make any sense. How many was I supposed to get? It's squared. There's 2. It's a repeated solution. It happens twice, which means it has multiplicity 2, which means what happens on the graph? It bounces. Yes. Probably. Probably Wednesday, either Wednesday or Thursday.
Can you do Thursday? Because I'm not going to be here Wednesday.
What's going on this week?
Wednesday, I'm not gonna be at school. It's Halloween.
Tell me this while we're right here. Look at that original equation. It is a lot of work. These are PRZs, but do you see, I could really give you one PRZ problem and I could test you on everything we've done in this unit. I could make sure it had a sum or difference of cubes. I could go through and make, like, I could put it all in one problem. I won't do that to you, but I could. I want you to look at this polynomial. What does the end behavior look like? Are they going opposite? Are they going same? In which direction? Sophia says this. Does everybody agree? Why? Even, positive. So without doing anything else, I know on both ends are up. I'm just sketching. I'm just bringing everything together that we've done. I know that the zeros are what? -2 and 1. And what happens? Do they go through or they bounce? They bounce. So I know it's got to come down and bounce off, but sometimes it's got to make it back to this one and bounce there as well. Does that look like a quartic? Yes. So I didn't really even have to do anything special with graphing to get all that. Okay, I've lost